Consider the given question. Using this question, using the given details, we are going to construct a network diagram and finally find the critical path and project duration for the given details. Let's begin by drawing a network diagram. So let's look at the details given. Now the first activity given in this question is 1, 2 is the first activity with time 4. So while starting to draw the network diagram, we must first look into which should be the first event. Now since in this question the activities are labeled with the events, it's easy for us to draw the network diagram. Now looking at the activities, we can see that 2 activities are starting with the event 1. That means, and 1 is the smallest number in the given set of activities, right? So 1 is the starting event in this case. In this network diagram, the starting event is labeled as 1. So we'll start with the first event 1. So I'm going to draw the first event 1. I labeled it as 1 and events are represented by circles. Okay. Now in this question we can see that the first 2 activities are starting from the first event 1 and they end at 2 different activities 2 and 3. So that means from the first event 1, 2 activities are starting from here and they end at different events, say 2 and 3. So I am going to draw an activity from 1 to 2 and the label that I am going to give on the arrow is the time duration for this activity. Okay, so this is the first activity that we have drawn, and then later we are going to draw the next activity, that is 1, 3. So that means this the second activity is also going to start from the first event 1 and it will end at the event 3 and label that activity by the time duration. Okay, now like this way we can draw all other activities and complete the network diagram. Okay, now we'll look at the next activity. The third activity in the given question is 2, 4, right? That means the third activity starts at the second event and it ends at the fourth event. We haven't drawn a fourth event till now, so before drawing that, make sure that if it has some other activities going to 4. So the third activity begins from 2 and it has to end at 4. The next activity is 3, 4. That means the next activity will start from 3 and it should also end at 4. So if I am going to draw this 4 here, there is an activity from 2 to 4 with duration 1 and another activity 3 to 4 with duration 1. Okay, now the next activity is 3, 5. That means from 3 we have another activity to 5. Since we haven't drawn 5 till now, we have to give a new event, say 5, and draw an activity from 3 to 5 with time duration 6. Now the next activity is 4 to 4, 9, right? Then from 4 we are starting the activity and label a new event 9 and mark the time duration 5 there. Okay, the next activity is 5, 6. So we have to draw an activity from 5 to 6. The next after 5, 6 activity we have another activity 5, 7 also. That means 2 activities are starting from 5 from the event 5. So I'm going to draw 6 here and 7 here. Okay, the time duration for 5, 6 is 4 and the time duration for 5, 7 is 8. The next activity is 6, 8. Let 8 be at this point and I'm going to draw 6, 8 activity with duration 5. Then we have the next activity is 7, 8. So from 7 to 8 an arrow goes with duration 2. The next is 8 to 10. So I'm going to represent the event 10 and draw an activity from 8 to 10 with duration 5. Next is 9 to 10. 9 is already there. From there I am drawing an activity to 10 with duration 7. So this is a network diagram. From the given details we get a network diagram like this. Okay, now we have drawn the network diagram for the given details. Now using this network diagram, we have to find the TE and TL values for each event. TE means the earliest event timing and TL means the latest event timings. So for each event in this network diagram, we have to find the TE and TL values. Okay, now let's start with the TE values. We will first compute the TE values for each event in the given diagram. Now take the first event, that is 1. The earliest earliest start time for the first event 1 is labeled as E1. The earliest event time for 1 is labeled as capital E1, and since it is the starting event, we assume that the starting event E1 is equal to 0. Okay, since 1 is a starting event, the earliest timing for the event 1 is 0. We start with the 0 value and then find the earliest time for the rest of the events in the network diagram. Now to find the earliest event for the event 2, we have to use, just look at the network diagram, you can see that we have reached the event 2 from the event 1, right? So the earliest timing for event 2, E2 will be equal to the earliest event time for 1 plus the duration of the activity. That is, E2 is equal to E1 plus the duration of the activity D12. Okay, I'll write it once more. Now, this was a network diagram, right? This was a network diagram. Earliest event time for first event E1 was assumed as 0 since it was the starting event. Now we are going to find the earliest event time for the second event 2, which is calculated from the previous event that has already occurred, right? So the previous event from 2 is 1, since from 1 we have an activity to 2, so the previous event for 2 is 1. Now we can compute E2 by adding E1 plus duration of the activity 1, 2. Now the value of E1 is 0. So 0 plus the duration for the activity 1, 2 is, it's clear that we have already written in the network diagram. So take that value and add it. Now we get that E2 is equal to 4. Okay. Now let's find the earliest time for event 3, E3. Now how do we find E3? Since we have the previous event for 3 is 1, we have to add E1 plus the duration for the activity 1, 3. By substituting the values, E1 is 0 and the duration for 1, 3 is 1. So E3 will be 1. Now next we will find E4. Now look at the event E4. The previous event for 4 is, we have 2 previous events for 4 since there are 2 activities ending at 4. So we have 2 options. So the way to find the E value for 4 is, if we have more than 1 activity ending at an event, we have to find the maximum value. Okay, so in this case E4 we can find by calculating the maximum of these 2 activities. Okay, so maximum of the first activity is 2, 4, right? So the duration or the earliest time for for the event 4 from the activity 2 will be E2 plus duration of 2, 4, and the earliest time, earliest time for the event 4 from the activity 3, 4 will be E3 plus D3, 4. So calculate these two values and give the value which is maximum to E4. Now let's compute that. We know we have already found the value for E2. E2 is 4. 4 plus duration for 2, 4 is 1. Then the next value is E3 plus duration of 3, 4, right? E3 we have got 1 plus duration for D3, 4 is 6, which means maximum of 4 plus 1, 5, and 1 plus 6, 7. The maximum of 5 and 7 is 7. So the earliest time for the event 4 will be 7. So like this way we have to find the earliest time for all the activities. Okay, for the earliest time, if we have more than one activity ending at an event, we have to find the maximum of both the paths. Okay, now like this we have calculated all the values for the events. These are the values we get for the events. Now this is the step-by-step method to find the earliest event timings for each event. Now this can be done without this step-by-step method, that is directly with the network diagram also. So directly on the network diagram we can find the earliest event timings as well as the latest event timings. Let's look into how we can directly find the earliest timings using the network diagram. So as we know that the earliest event timing for the first event is 0, we will label that on the figure. So here for the event 1, E1 is equal to 0. Okay. Then we are going to find the earliest event time for the second event 2. Now, before we have the step we used to find E2 was E1 plus D duration of 1, 2, right? Duration of the activity 1, 2. That is the same step what we have to do, but instead of writing it as a step, we can directly calculate the value. So the step is if we have to find the earliest time for the event 2, then we have to add the event time, the earliest, the E value of the previous event plus the duration of the activity, right? So the event which comes before 2 is 1, right? So the earliest value for 1 plus the duration for the activity 1, 2 will give the E value for 2. So the E value for 2 will be 0 plus 4, that is 4. Now the E value for 3. The previous event for 3 is 1. So E3 can be calculated by adding the earliest value of 1 plus the duration. That will be 0 plus 1, 1. Now, in the case of 4, we have 2 paths, right? That means we have 2 events as previous events for the event 4. We have 2 and 3 as a previous event. So, we have 2 paths. You have to calculate the value from each path and then take the maximum value. So, for E4, the answer will be maximum of 4 plus 1 and 1 plus 1. Which will become 4 plus 1 is 5 and 1 plus 1 is 2. So, 5 will be assigned to E4. Now, to find E5, we have only one previous activity, only one previous event. That means add this E3 plus 6. That is 1 plus 6, we get 7. Now, E6. The value of E6 will be the previous event for 6 is 5. So, E5 plus 4. 7 plus 4, we get 11. The next E7 is equal to the previous event is 5. So E5 plus 8, that is 7 plus 8, 15. Next, in the case of E8 is equal to, we have 2 events before 8. So maximum of these 2 parts, right? That is E6 plus 1 and E7 plus 2, the maximum of these 2 values. It is 11 plus 1, we get 12. So we get 12 from here, and from here 15 plus 2, it is 17. So the maximum of 12 and 17 is 17. Right, that way we assign the maximum value for E values, right? Then E9, E4 plus 5, that is 5 plus 5, 10. And last E10 is equal to maximum of these two values, that is maximum of 10 plus 7 and 17 plus 5. 10 plus 7 we get 17 here, and here 17 plus 5 we get 22. So maximum of 17 and 22 is 22. So these are the E values we get. Like this way we can also find the latest event timings also, that is the L values for each event. We can use either we can calculate the L values either from the diagram directly or using the step-by-step method as we have done for the earliest event timings. Okay, now let's find the TL values for each event. First we'll do it using the diagram itself. From the we'll do it directly on the diagram. So we are going to find the TL values, where TL means the latest event timings. So for each event we have to find the latest timings for each event. The latest time to find the latest timing, we start with the last event. In the case of earliest time, we started with the first event and we initialize the event time for the first event as 0. Now to find the latest event timings, we start with the last one, and we assume that L10 is equal to E10. Since it's the last timing and it's the last event, we start with the value we got for the earliest time for the last event, right? So L10 is equal to E10. So we get L10 is equal to 22 in this for this question. Okay. So we start to find the latest event timings. We start with the last event, and we assume that L10 is equal to E10. That is, in this case, the value is 22. From here, by backward pass, we find the L values for each event. In the case of E values, we used forward pass to find the event timings, earliest event timings for each event. For backward, we use backward pass to find the L values for each event. Okay, and we start from the last event. The last event, in the case of last event, L10 is equal to E10. That is, in the case of last event, the L value and the E value are same. So we get L10 equal to E10, which is 22. From there, we find the L value for each event. Now we are going to find the L value for 9. That is L9. So in this case, we have the L value for just L10, right? We know the L value for L10, and using that we have to find the L value for the event 9. That means we have to, the equation for that is L10 minus, since we have an activity from 9 to 10, we can find the value for L9 by subtracting L10 and the duration, time duration for the activity. That is, the formula will be L10 is equal to L9 minus duration of that activity. That is duration of the activity 9-10. As we know that we have assumed that L10 is L9 equal to L10 minus duration of the activity 9-10. We have assumed that L10 is 22. So 22 minus the duration of the activity 9-10, that is 7. Okay, this is how we get the value, which is equal to 15. So we get L9 as 15. We get L9 as 15. Now find the value for L8. So in this case, we know the values for L10 and L9, but we have an activity only from 8 to 10. So the next event, so in the case of latest event timings, we use the next event which we already know, the event value which we already know. So to find L8, we are going to use the L value from L10, since we have an activity from 8 to 10. So L8 can be found by subtracting L10 and the duration of the activity 810. That is L8 is equal to L10 minus duration of the activity 810, where L10 is equal to 22. So 22 minus duration of 810 is 5, which means we get 17. So L8 is 17. Okay, now to find the value for 7. So L7, to find L7, look, we have an activity from 7 to 8 and we know the L value for 8. So L7 can be calculated by subtracting L8 and the duration. That is 17 minus 2, we get 15 for L7. In the case of 6, L6 is equal to, we have an activity from 6 to 8, right? So we can find L6 by subtracting L8 and the duration. So 17 minus 1, we get 16 as L6. Okay, now to find the case, find the latest event for the event, latest time for the event 5, we look how we can find. See, to find L5, you can see that we have two activities from 5. We have two activities emerging from 5, 1 to 6 and 1 to 7. So we have two paths here, and so in this case we are going to find the value from both the paths and then take the minimum value. In the case of earliest event timings, if we had more than one path, we took the maximum value. For latest event timings, we will take the minimum value of the given options. Okay, so to find L5, we have two paths. We have to find the value from each path and take the minimum of these two. Okay, so L5. So L5 can be written as, L5 is minimum of which all values? L6 minus duration of 5, 6 and L7 minus duration of 5, 7. Right, which is minimum of L6 is 16. 16 minus the duration of 5, 6 is 4, comma. L7 is 15. So 15 minus duration of 5, 7 is 8. Which means minimum of 16 minus 4 is 12 and 15 minus 8 is 7. Minimum of 12 and 7 is 7. So the value for L5 is 7. So value for L5 is 7. Okay, like this way we have to find the L values for the rest of the events. So to find the L value for 4, L4 will be, you have only one activity from 4 and that ends at event 9. So L9 minus 5. So 15 minus 5, we get 10. So L4 equal to 10. In the case of 3, we had two parts. You have to find the, you have to take the minimum of these two, right? So minimum of L4 minus 1 and L5 minus 6. L4 is 10. So 10 minus 1, 9. And here 7 minus 6, 1. That is 9 and 1. The minimum of 9 and 1 is 1. So L3 is 1. Now to find L2, we have to find L2 also. So L2 is L4 minus 1. 10 minus 1, we get 9. In the case of L1, we have two parts. So we have to take the minimum of these two. That is L2 minus 4 and L3 minus 1. That is 9 minus 4 and 1 minus 1. So minimum of 9 minus 4 is 5 and 1 minus 1 is 0. The minimum of 5 and 0 is 0. So when we find the L values using the backward pass, when we reach the first event, the values of E1 and L1 should be equal. If it is equal, then we can say that what we have found, the values we have found are all correct. Okay, so by backward pass, we have found the values of each event, the L values of each event, and we got the L1 as 0. Okay, so these are the earliest and latest timings for each event. These the backward pass can be written in the step-by-step method like this. The steps to find each value are written here. By that method also we can write. So this is how we find the earliest and latest event timings for all the events. Now for the given question, we have constructed the network diagram and found the TE and TL values for each event. Now next we have to find the earliest and latest event timings for all the activities. That is earliest start time EST, latest start time LST, earliest finish time EFT and latest finish time LFT. These timings are to be calculated for all the activities. After that, we'll find the critical path and project duration. Now, to find the EST, LST, EFT and LFT values, we'll construct a table and find the values for all these terms. So, this is the table. These are the table headings. So, this is the table we are going to use to find the values for EST, LFT, LST and LFT. Okay, and total float is to be calculated to identify the critical activities. We can find the critical path only by identifying the critical activities. Critical path is a sequence of critical activities. So to find the critical activities, we have to find the total float. So these are the table headings that we are going to use here, and we will find the values for each activities corresponding to the table headings. Okay. Now, the first column for the table is the activity. The list of activities will be written here. All the activities are written here and the time duration is given in the second table. Now, first we are going to find the EST values. The EST value means the earliest start time for an activity is called the EST values. So, EST means the earliest start time. As you all know, the earliest start time of an activity is the earliest time of the tail event of that activity. For example, I'll take the first activity. The first activity is 1, 2. So, the earliest start time for the activity 1, 2 is the earliest time of the first event. That means here EST means EST of the activity 1, 2 is the value of E1. Since E1 is the 1 is the tail event and the earliest event time for 1 is labeled as E1. Okay. So EST means earliest start time of an activity, which is equal to the earliest time of the tail event of each activity. So in this column you have to write the E values, that the earliest values of all the tail events in the activities. For the first activity 1, 2, we'll write the value E1. Right. What's the value of E1 from the table? You can see that E1 is 0. So EST for the activity 1, 2 is 0. Now for the second case, for the second event also, the tail event is 1. Tail event is a starting event. The tail event is 1. So the EST for activity 1, 3 is E1 again. So here also we write the value 0. Now the next activity is 2, 4. So EST for 2, 4 is the value of the earliest value for the event 2. That is, here we have to write the value of E2. From the figure, E2 is 4. So write the value of 4 there. Like this way, you can write all the EST values for the activities. So the next value is E3. The value of E3 is 1. Here also E3. Here E4, value of E4 is 5. Here E5, that is 7. Here also 7. Then like this way you can write all the values. Now I have written all the EST values. These are the EST values for each activity. Now to find the EFT value. EFT is the earliest finish time of an activity. If you have written the EST values, then EFT can be calculated as, the formula for EFT is EST plus duration, the time duration. Okay. EFT is equal to EST plus duration. So you have to just add the time and EST values for each activity. So for the activity 1, 2, the EFT value will be 4 plus 0. You get 4. For the activity 1, 3, EFT is 1 plus 0, that is 1. So by adding these two columns, we get the values for EFT. So these are the EFT values which you get by adding these two columns. Now we have to find the latest time. So we start with LFT value. Since LFT means the latest finish time of an event, of an activity, it is equal to the latest event timing of the head event. So in this case, in the first case, for the first activity 1, 2, LFT is equal to L2. Since 2 is the head event for the activity 1, 2, the value of L2 will give the value is assigned as a value for LFT. So LFT is equal to L2. Here the value of L2 from the figure is 9. So LFT for the activity 1, 2 is 9. Now LFT for the activity 1, 3 is L3, which is equal to 1. L3 equal to 1. Like this way, write the LFT values for each activity. You have to write the L values of the head events. Okay. So after writing all the LFT values, you get like this. You'll get the column like this. Now we have to find LST value. That can be found with the help of LFT. LST is equal to, LST is the latest start time. If you know the latest finish time and the duration of each activity, you can find LST by using the formula LFT minus duration. LST is equal to LFT minus duration. That is 9 minus 4 will give you the LST for the first activity 1, 2. This 9 minus 4 is 5. Next is 1 minus 1, 0. 10 minus 1, 9. Like this way you can find the LST values for the remaining activity. Now we have found all the timings for the activities, that is EST, EFT, LST and LFT values for each activity. Now we are going to find the total float to identify the critical activities in this network diagram. To find the total float, the formula used is LST minus EST, or you can use the formula LFT minus EFT. Either of the formula can be used to find the total float. Both will give you the same answers. Okay, so total float can be found either by subtracting LST and EST or by subtracting LFT and EFT. So in this case, I'm going to subtract the starting values, that is LST and EST. So the first value we'll get is 5 minus 0, that is 5. Next is 0 minus 0, that is 0. Then 9 minus 4, 5. Like this way you'll get the total float values for the remaining activity. These are the float values that you get after applying the formula. Okay. Now the critical activities are identified by look at the float values. So if the total float is equal to 0, then that is a critical activity. So all the activities which have a float value 0 will be the critical activities of this network diagram. Okay, so we have a 0 here, that means 1, 3 is a critical activity. Then the next critical activity is 3, 5. The 3, 5 is the next critical activity. We have another critical activity, say 5, 7. Then we have 2 here, that is 7, 8 and 8. These are the critical activities of this project. So the critical activities are 1, 3, 1, 3, 3, 5, then 5, 7, 7, 8 and 8. These are the critical activities of the network we have drawn. So this is to be represented in the figure, in the network diagram we have drawn. So taking the network diagram, mark the critical activities using double arrows, double line arrows. Okay, so 1, 3 is a critical activity. So I am drawing a double arrow for the activity 1, 3. Then the next activity is 3, 5. So from there 3, 5 is given a double line. Then you have 5, 7. So from here 5, 7, I'll give double line for 5, 7. Then 7, 8. And last 8, 10. So these are the critical activities. After drawing double line for all the critical activities, you can clearly see the critical path in the network diagram. So the critical path is 1, 3, 5, 7, 8, 10. So this is the critical path for the network diagram. Okay, so this is the critical path. So we'll write the critical path like this. So this is one answer that we have to show. Then from that you can find the project duration. So the project duration is calculated by calculating the time, the duration, the timings given in the critical path. That is 1 plus 6 plus 8 plus 2 plus 5 will give the project duration. You will get 22. This is how we find the critical path and project duration for a given network by using CPM method, that is critical path method.